All right, good morning. We'll go ahead and get started. Welcome to the 10-4 Tech Talk for June 2017. My name is Scott High. I'll be hosting today. I'm a Tech Services Manager here at 3D Vision. And with us this morning, our guest speaker is Robert Warren. Robert has 16 years of experience in the CAD/CAM industry. 10 of those years are with 3D Vision. He's been working alongside me, so Rob and I have known each other for a long time, and we're glad to have him here this morning. So he's been here with us 10 years doing SOLIDWORKS simulation support, and he has a lot of real-world experience utilizing FEA to solve complex structural problems, and many years supporting and training customers in a wide variety of analysis applications. Good morning, Rob.
Good morning, Scott.
All right, so Rob, I think this morning we're going to be looking at a pretty unique application for flow analysis. So why don't you tell us this morning what we're going to be looking at and what you're going to take us through?
Yeah, so today we're going to be looking at an as seen on TV model. I ended up kind of coming across this one night, and I just want to kind of look at the initial thoughts, some setup on that, use of the Transient Explorer with regards to flow, and then maybe run through a steady state analysis. So I don't know if I'm like many people, but I usually get sucked into that as seen on TV trap. So late at night, I'll be up working on something and end up, kind of seeing some of these ads, whether it's through a home shopping network or just an infomercial. But I certainly get hooked on those, and I just kind of want to know, do they actually work? Well, one night over Christmas break, I was up late with my son. He had the flu. I was trying to keep his fever down. And I ended up on a channel that is known for its quality, value, and convenience. And they were selling this iced up appetizer tray. And, as the chef was talking about it, he talked about putting ice in the top and how the cold air descends on the food and it keeps it cold for hours, and you can take it to a picnic and everything's good. And that really got me thinking, what can I do, or how do I know that this will work? So what I wanted to do was actually utilize flow simulation to kind of find out, whether it did work or not. So the first thing we want to look at is just some initial thoughts, talk about the setup of this, and some of those material assumptions and so forth. So when we switch over to SOLIDWORKS, what we're going to see is, I modeled this based off of all of the dimensions inside or on their website. So they gave you the full size of it, actually some screenshots of it. So I modeled it up. I also put in some cheese, some vegetables, and fruit, just to kind of get a feel for what was happening to those inside of this structure. I also added wedges of ice to kind of give more surface area to the ice at the top. And what you see here is I'm just going to turn on Flow. We're going to start talking about the setup inside of Flow Simulation. So Flow is an add-on to SOLIDWORKS. You end up with a tab in the Command Manager, and there's a wizard that walks you through setting up the process. So it's very straightforward, very easy to do. First thing we need to do is name the study, and then from there pick our units. So even though I want to do everything in inch, pound, second, maybe I want my temperature to be something different like Celsius or Kelvin. You can set those up appropriately. I want to do an external analysis with this, and then I also want to turn on time dependency to make this a transient analysis.
So a transient analysis, Rob, so my understanding is that that's going to allow us to look at the temperature in this container over a period of time, not just at one instant in time. Is that what that means?
Yeah, you're exactly right, Scott. So for this type of an analysis, because the food is going to be at a different temperature than the ice, I want to see how long does it take for things to cool down and understand that natural buoyancy effect with time of what's happening inside of this appetizer tray. So a transient analysis is really required in order to do that.
Okay, got it.
So what I'm going to do here is just extend the amount of analysis time. This, at first glance, is just a guess, but we can always increase that. Then I'm also turning on gravity to, again, take into account that natural buoyancy of cold air descending and hot air rising. I'm going to use air as my default fluid. And then for my default container, for my solid container, I can either use plexiglass or polycarbonate. For this, polycarbonate actually is probably the better choice, because on the website they said that it's made out of aircraft window material, which is polycarbonate. I'm also setting my default ambient temperature to 72 degrees. So on a spring, late spring, early summer day here in Ohio. That's a pretty normal temperature. Once the study is generated, I can then add materials to my cheese, to my fruit, to my veggies. And in here, the bulk of what took me the time for the setup was just finding those properties. So I did some research on Google, pulled up some PDFs of other people that have published that, and put those properties in there. So we have appropriate heat transfer rates and so forth for the food. Here I'm specifying a constant temperature of 0 degrees Fahrenheit for the ice. That's the temperature that my refrigerator makes the ice at. And I'm just holding that constant, making sure that it is not necessarily melting. I'm giving this all the benefit all the benefits of just holding a constant temperature. From here, I'm also adding in goals. So the goals are important to understand what is the average temperature, heat transfer rate, and so forth.
So Rob, in just a few minutes here, it looks like you've set up all the properties that we need, how the air is going to flow, whether the temperature is going through the solid material or not, and then you put some goals in here. So it didn't take very long to set up, but I know you've thought about this prior to the presentation today. How long did it take to set up the first time? Because it didn't seem too challenging.
Really, it was just a matter of minutes. What you saw here was the setup that I would have ran through the first time. What took the longest was actually finding those properties of the food, because those aren't necessarily default in the library. But once I had those and I generated those custom properties, the setup is very straightforward.
Okay, yeah, because I think that's one of the myths with simulation. We hear simulation and analysis, and maybe guys like me that don't use it every day, we start to think, boy, that's going to be really tough to set that up. But it really seems like just thinking through what's really going on in the real world, and then the ease of use in the interface, just kind of like SolidWorks, it's fairly easy to set up.
Yeah, that's exactly right. So unlike this appetizer tray, several of our customers don't necessarily use Flow for that aspect. We actually have a customer that makes custom exhausts. So Flow can be used for any application that has fluid going through it or has thermal constraints. So in this case that you see right now is a server room. So we can use Flow for heating, ventilation, and air conditioning, giving out comfort parameters of certain areas. The medical industry can use it. This is an oxygen diffuser that tells you how much oxygen is being delivered and at what rate, mass fraction rate. So there's a wide range of industries that can utilize Flow. Pretty much anybody that is looking at some type of fluid flow, whether it be gas or a liquid, can benefit from CFD and the essentially unlimited iterations that you can run virtually rather than doing those physical tests.
Yeah, Rob, one thing I've been seeing and working with Brian with SolidWorks PCB and thinking about all the Internet of Things and all the devices now that have electronics, one thing that always has to be dealt with is cooling. And so ironically, that's going to maybe bring up the demand and need for tools like Flow.
Yeah, exactly. So we do have an electronics cooling module as well, specific to electronics and joule heating and 2 resistor components and all of that. So I just want to take a poll question here. And have you ever ordered a gadget from TV commercials? And be honest, if you have one of those backwards robes that everybody calls a Snuggie, even if it's camouflage, be honest. Let us know if you purchased something from there.
Are we allowed to put yes if our spouse has bought something on the infomercials?
I believe so. So it looks like actually 100% of you said yes. So I think Scott, that might be where the money is. We have to come up with some gadget that we can sell on TV.
Maybe we can sell SolidWorks Flow on the late night shows.
That would be perfect. So we ran through all the setup inside of SolidWorks. We set up the tree. What I want to look at now are really those results of the transient analysis. So what I'm going to do is over that time that I solved the solution, I have 1 second increments that I can look at given time steps of the solution. So I'm just going to look at 1 minute in, and I want to see what is the temperature with regards to the flow and what we're going to see. So I'm going to go ahead and generate a cut plot here and take a look at what that temperature is. And if I look normal to it, kind of drag the legend off to the screen, I'm actually going to utilize the probe tool. And the probe tool is actually a phenomenal tool. It's underutilized sometimes. But as I move my cursor on the screen, it's giving me live feedback on that section of what the temperature is. And so we can see that we do have a cold air kind of descending right underneath where the ice is, but towards the outside expanses of the appetizer tray, it really is still warm. It's still at that 72 degrees or 60-some degrees. What I'm going to do here is look at it a little bit further into the solution, so at 240 seconds. In using that probe tool, we can see that cold air is truly descending. It's doing what they said it would do, but it's staying in a column. It's really not mixing inside of that environment. So you can see, yeah, it's pretty cool underneath where the ice is, but as you go out towards the sides, our cheese is melting, our mushrooms aren't doing too well. So leaves me kind of wonder what's going on with this design. Here I'm just going to look at a surface plot, and that surface plot is again of temperature, but with the probe tool we can see, hey, our fruit's right about 55 degrees, the cheese is about 56, so that's melting. I can't stand warm cheese. And then, our vegetables are pretty hot as well.
Rob, I'm okay sacrificing those mushrooms, but let's try to save the tofu up there.
Yeah, so if this is my picnic, that is definitely not tofu. What that is perfectly sliced cantaloupe or watermelon. So I'm really precise when I cut my fruit.
Okay, let's work to save the cantaloupe.
Yeah. So what we can see here is kind of a history of the convergence and some average values for the temperature. So we're seeing average values based on those goals that we set up, 61 degrees, 62 degrees, 63 degrees. So we're not at those refrigerator temperatures, or just a little bit above those refrigerator temperatures with the analysis. So I do want to offer a giveaway. That link is going to be in the chat window. So 3D Vision tries to put together a lot of blogs that focus on new things inside of Flow. This one has a new trick in Flow Simulation that was offered last year. So we do have that giveaway for you. I also want to do a second poll question. So, if you're currently doing physical testing, whether it's for CFD or FEA, how long does that testing take to complete? In my experience, when I was in industry, it was several days to a week. But sometimes it could be less than a day, 1 to 3 days, longer than a week. How long, if you are doing physical testing, is that taking you?
I suppose this is particularly challenging with flow. I mean, even just structural testing is tough, putting sensors and things on it, but I imagine the flow's even more challenging.
It is because usually you're dealing with like an airflow. You have a flow bench that you have to put, your apparatus on, not even counting the time to manufacture the prototype, but then you have to do all the physical testing along with it. Or, if it's for water valves or something, you have a whole room usually associated with that has different water pumps in it, different manifolds, different valves to kind of meter the flow. So it can be a very lengthy process, doing physical prototyping and testing. So it looks like the bulk of you who did vote, it looks like 3 days to a week is about an average time. So, if you were able to kind of knock that down virtually, this may be a good time saver for you. Next thing that I want to look at is the Transient Explorer. So we did a transient study. We looked at it at given time steps or time increments. But I want to show you a new way that was added to kind of view these results. So if we go back to our flow simulation and we start looking at the analysis, under the calculation control options before you solve the study, you have to turn on the Transient Explorer. Once that is on, you load those results. So I've done this previously. And what you see here is we now gain access to this slider. And this is actually so beneficial because what you're seeing here is as I drag that slider back and forth is how that temperature is increasing or decreasing from 0 seconds to the extent of where I stopped this simulation, which was at 268 seconds. So you can see how that temperature descends, how the air increases or decreases. We can also go in and narrow that band and have an even better understanding of what happens in between 203 seconds and 240. So the Transient Explorer is a huge leap forward in viewing these types of results versus just pulling up individual time moments like we did previously.
So Rob, this isn't just a video. I mean, because you're dragging the little slider on, it looks like kind of a video editor, but I'm doing more than just scrolling through a video. I mean, I'm able at each one of these points, once I visually see it, can I go in there and start probing at that particular point?
No, you're exactly right, Scott. So it's not just a video. What it's doing is displaying the results live as I move that slider. So at each instance where I stop my slider, I can go in with my probe tool. I can pick up those given values, and we can save that off as a screen capture, or we can save those probe values into Excel, and it'll mark what that temperature is. So it's a really nice feature. The other aspect of it is we can actually then save out the AVI of this very easily. We don't have to go through the animation wizard anymore.
Yeah, it's really nice.
So I wanted to do another giveaway, and this is another blog by Bill Roos. And again, that link will be in the chat window, but this is a blog specific to the Transient Explorer and all the nuances on how to use it. But the setup is very straightforward through the calculation control options. So let's talk a little bit about steady state. And, what I did here, typically what you would do with an analysis is use steady state as your first setup. Just see how are the boundary conditions working, how are the initial conditions changing, and it's a faster solution that solves pretty quickly. I actually took and worked this a little bit backwards, and the reason being is I started off with the transient knowing that I wanted to see how the air cooled, but I quickly realized that with this analysis, it reaches steady state pretty quickly, and I wanted to see, hey, if we make the assumption that the ice is at 0 degrees all the time, the ambient conditions of the temperature on the outside stay constant, no matter how long this sits there, what are going to be the temperatures inside of this apparatus? And what we see is they are lower. They are lower than where I solved through with transient, but not much lower. You can see that the ribs there definitely cooled down, but we still have that one cold column of air in the middle, and on the outside, you can see we're still at 60-some degrees. So it leads me to the conclusion that this may not be the best or most efficient way to do heat transfer for this type of device.
So, Rob, one of the things about simulation, so in this case, we're questioning whether or not this particular design is going to do what was advertised. But if we're designing this and we come up with this conclusion, like, what else? One of the things about analysis, right, is I can try different things. So maybe what would you try here? You said the cold air is not really getting to the outsides. Could we put a little battery operated fan underneath the ice or something? Or what could we do there?
Yeah, a fan would be a good option to kind of circulate the air inside of there. That now it's a forced convection type problem. That would certainly work. But because we're right inside of SOLIDWORKS, we can leverage that data so we can make these ribs thicker. We can maybe change the materials of the bottom of this. And I personally probably would put the ice underneath to have it conduct through to the vegetables, as well as do some convection, natural convection in there as well. The interesting thing is this company that makes this actually has a dip tray as well that has the ice directly underneath it. So I thought that was interesting, but that probably would be the next design iteration that I would do. But Flow certainly gives you the ability to do that because we're right inside of SOLIDWORKS.
Yeah, that's, just in simulation in general, whether it's Flow or something else, just being able to run through multiple iterations and, think out of the box and just try different things that you may or may not try to do if you had to do a physical prototype to work through different design iterations.
Yeah, you're exactly right. It allows you to do those what ifs very, very effectively. So I do want to do another poll question. So if you currently outsource CFD or actually even any analysis, so FEA or plastic injection mold analysis, how often do you do that? Is it every project? Is it only when you're required by your customer to provide some results? Do you do it rarely, or maybe you want to do it all the time, but the budget doesn't necessarily permit that option?
All right, go ahead and close that poll. Let's see what you got.
So it looks like for those of you who voted, it is actually every project that you are outsourcing your analysis. So that can be costly, and if you could bring that in-house by use of our simulation products, you're able to try multiple iterations, not just the one that you sent out, as well as save a lot of money and time doing that.
Yeah, I think with Flow particularly, like we talked about, the trying to do prototyping it's difficult unless you have a lot of equipment that's specifically designed for that. So really, you don't have a whole lot of options outside of either sending it out or trying to bring this type of technology in-house.
Yeah, you're exactly right. I did just kind of want to give an overview of all the simulation products that we do offer. So we offer for our structural or our finite element analysis package a premium, professional, and standard with different modules that are associated with that. And then included in SolidWorks Premium is static linear analysis and motion analysis. So if you have SolidWorks Premium, I highly encourage you, if you have structural needs, check out those options. You already own them. From the CFD side, we do have flow simulation. So everything that I showed you today was in the core flow simulation package, but we do have modules or add-ons, HVAC for specifically HVAC design, and then the electronics cooling module, like Scott mentioned earlier, for making sure, hey, my electronics in this enclosure are going to last based on, cooling and so forth. And then we also offer 3 levels of what we call as simulation plastics or plastic simulation. And what that is injection mold analysis. So from standard, where you're just designing one part and making sure that it can fill, all the way through, you're the mold maker and you need to know, is it going to warp after it's ejected? And, where are my cooling lines? Are my cooling lines being efficient? So we do offer a wide range of products on the simulation side. So I wanted to open this up to any questions. Please put those in the chat window, and we'll take a look.
All right, let me check Rob and see if we have any questions coming in. So it looks like the only question we have is what does it take to get trained in Flow? What do we offer with regards to that? Say, for example, to get up to speed with what you were able to do this morning.
Yeah, so 3D Vision offers this a 2-day class for Flow Simulation, and it covers everything from the interface, which is really intuitive because we're inside of SolidWorks, all the way through doing some of these more advanced analyses such as thermal analysis, maybe rotating regions, things like that. But that class covers all of that, as well as there are tutorials built into the software to get you started right from the very beginning until you can get to class. So there's many options for that.
So if somebody listening or watching this morning is curious about whether our tool is a fit for them, what's the best way for them to go about that? Could they reach out to you directly to find out and just have a chat with you, or maybe you could show them some things? What's the best way for them if they've got those questions?
Yeah, so the best way would be probably just directly to contact me. We can do, just kind of have a conversation of what you're doing currently, where flow simulation would be a fit, and then after that, if we felt that it was a fit, I could come out and actually show them the product a little bit more, less time constraints, should I say, kind of really drill down into all the different options that Flow has and just kind of show the software.
All right, very good. I'm going to go ahead and post your email address out there in the chat window, so if you get a bunch of spam, that's my fault. But if those of you that are watching want to reach out to Rob, he'd be more than glad just to talk to you and say, hey, what's your situation? What are you trying to accomplish? And we'll let you know if it looks like it's an application, and then we can move from there if that's something you're interested in.
All right, perfect.
All right, looks like we have no more questions. So thank you, Rob, for presenting this morning. I'm always looking forward to your presentations and your blogs. I know you've analyzed some of your children's bath toys and the effectiveness of those, and this morning the chilling, and also you're always helping the Boy Scouts create the best trebuchets since their father has access to simulation tools. So always look forward to your presentations and blogs, so thank you.
All right, excellent.
So thank you all for attending our Tech Talk this morning. We will be having one next month on July 27th. So the topic's going to be DriveWorks is faster than starting from scratch. So if you're not familiar with DriveWorks or you're curious about that, what we'll usually ask when somebody has interest in it is, do you do things that are the same but different? Right? It's kind of like the same model line, but the attachment's different, or it's the same model line, but the sizes are different. Those kind of things, we see so many customers still starting from scratch or just doing a save as in SolidWorks and trying to edit things. There's easier ways to do that, and DriveWorks can certainly help with that. So if that's something that would interest you, be sure to come back next month and attend the Tech Talk. So thank you for attending this morning. We appreciate it, and have a great day.